Chapter 8, Right Triangles. Today we're going to cover section 8.3, the converse of the Pythagorean theorem. Your class opener, find the value of x. The objective today, after studying this section, you'll be able to state and apply the converse of the Pythagorean theorem and related theorems about obtuse and acute triangles. Theorem 8.3. If the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So it's pretty much saying, if you take the numbers and substitute them into a squared plus b squared equals c squared, and the values work out, you happen to have a right triangle. So it says, determine if the following side lengths form a right triangle. The most important thing is remembering that the largest side of the triangle has to be the hypotenuse. So for number 1, I have to make sure that the 14 goes in for c squared. So let's check and see if it works. Does 9 squared plus 12 squared equal 14 squared? Well, let's go through and check. 9 squared is 81. 12 squared is 144. 14 squared, don't remember it off the top of my head, which is fine. Just means we grab our calculator and check out what is 14 squared. So 14 squared is 196. And then I need to add the left side. What's 81 plus 144? And does 225 equal 196? No. So are these values forming a right triangle? No, they're not. Number 2. First thing I notice is which one of these is the largest. And I don't know if 2 times the square root of 33 is going to be the largest value. So the easiest way to figure that out is go back to your calculator and figure out what is 2 times the square root of 33. So I'm going to do the square root of 33 times 2. And it's only 11.4, so that's telling me that my largest value is in fact going to be the 14. So let's go through and set this one up. So 8 squared plus 2 square roots of 33 squared, and checking to see if it equals 14 squared. Well, 8 squared I know is 64. If I distribute, let's see, I get 2 squared is 4. The square root of 33 squared is going to be 33. And 14 squared I know is 196 because we just did that in the last problem. And let's see, 64 plus 4 times 33 is 132. Add 64 and 132. And look at that, the Pythagorean theorem works. So that means that yes, this has to be a right triangle. Okay. Here are some Pythagorean triples. So if you notice that the values of a triangle are 3, 4, and 5, it's a right triangle. And also if you take those values and say multiply them all by 2, if you see in a triangle 6, 8, 10, or if you've multiplied the original numbers by 3, so 9, 12, 15, those are automatically going to be sides that form a right triangle, and the other values up here are some other ones as well. I think the one that a lot of people remember those, 3, 4, 5. Okay. Here are the next sort of 3 theorems. Here's what it's pretty much saying. If you try Pythagorean theorem and everything works out, you have a 90-degree angle and you get yourself a right triangle, which makes perfect sense. If you try to do the Pythagorean theorem and the c value is too small, it just means that instead of a 90-degree angle, the angle is a little too small, which gives you an acute triangle. Likewise, if you try Pythagorean theorem and your c value is bigger than what it should be, it just means that the angle is bigger than a 90-degree angle, and it means that you have an obtuse triangle. Let's look at some problems now. Is a triangle formed with the given lengths? Is it acute, right, or obtuse? So checking to see if this even works. Let's see. Largest value out of here, let's check and see how large is 5 times the square root of 5 to see if that's going to be our biggest value. So I have the square root of 5 times 5 is 11.1, so that is going to be my largest value. So I'm thinking here's going to be my C value. Let's try Pythagorean theorem. 8 squared plus 9 squared equals 5 squared to 5 squared. 8 squared I know is 64. 9 squared is 91. Distribute, 5 squared is 25. Square root of 5 squared is 5. I know that 25 times 5 is really 125. And on the left side, 64 plus 91 is 155. Now, the thing that I do is I like to compare what's happening to the C value. Okay. So my C value is smaller than it needs to be a right triangle, which means my angle is smaller than a right angle, which means that this is going to be an acute triangle. Let's look at number 4. I know my C value over here is 13, which is the largest value, and let's check and see what happens. 3 squared plus 12 squared equals 13 squared. 3 squared is 9. 12 squared is 144. 13 squared is 169. And if I add 9 and 144, I get 153. And now I'm always checking what's happening with my C value. My C value is bigger than what it would need to be a right triangle, which means my angle is bigger than a right angle, which just means that this happens to be an obtuse triangle. Use the information to decide if triangle ABC is acute, right, or obtuse. So let's fill in the information. AC is 10, BC is 17, and CD is 8. And they're asking me to find what's happening with triangle ABC. Okay. So to do that, I have a couple things to look at. I really need to know how big AB is. Well, if I look at this triangle right here, I can find out how big AD is. And if I look at this triangle over here, let's pick a color that's a little different. So if I look at this triangle over here, I can figure out how big DB is. I'll call that Y. And I can actually figure out how big is AB and figure out the triangle that I need. So let's figure out the X value by doing Pythagorean theorem. And I know there's a right angle right here. So X squared plus 8 squared equals 10 squared. So I get X squared plus 64 equals 100. Subtract off 64, X squared equals 36. Take the square root, X is 6. So I know that this piece is 6. Now do Pythagorean theorem over on the right. 8 squared plus Y squared equals 17 squared. 8 squared is 64. 17 squared, let's see what that is 289. Subtract off 64, and I get 225, square root each side, and I get that Y is 15. Okay. So now, looking at this, I now realize that AB is 21. So now I'm going to go through this problem and using the values in the large triangle, I'm going to try Pythagorean theorem and see what happens. So what am I going to get when I do 10 squared plus 17 squared equals 21 squared? All right. 10 squared is 100. 17 squared we figured out earlier was 289 equals 21 squared. Let's see what that is. That is 441. And then we can add up. 100 plus 289 is 389. And again, I'm going to compare what's happening to my C value. My C value is larger than it needs to be a right triangle, which means that I'm going to end up with an obtuse triangle. And your closure. Using only the side lengths, explain how to determine if a triangle is acute, right, or obtuse.